Hi, I'm Matt Ducasse, a fifth year EE minoring in computer science. This is my beta demo of my senior project, the sensor module for the C-Star 3 system. C-Star is a camera system designed to autonomously photograph deep ocean ecosystems. During deployments, the C-Star system will be fastened to an anchored rig and lowered to the seafloor, where it will take photographs on timed intervals over the course of several months. At the end of its deployment, it is retrieved and the photos are loaded from its SD storage. The next iteration of C-Star will feature sensor module that, when pulled by the camera module, will record data from its connected sensors. The sensor module is Arduino based and has several channels that can be configured to read from either serial, I2C, or SPI sensors. My contribution to the project is designing the Arduino code for the sensor module, providing an API for the camera module's Raspberry Pi to interface with the Arduino over serial, as well as characterizing the Arduino's power consumption and clock drift. A major component of software design was implementing the serial protocol between the camera module and sensor module. All exchanges start with a request packet from the camera module and are followed by a reply packet from the sensor module. Request packets currently feature a 5 ASCII character array. The first is a $sign to indicate the beginning of a request. The next is a destination ID, indicating which module the packet is intended for. Next are 2 opcodes indicating the type of operation requested. And last is the SSM channel to operate on. For instance, 1RD3 means to read data from channel 3 of module 1. After the operation takes place, a reply is returned with the following format: an asterisk to indicate that the request was good, a destination ID, a number of bytes of data, and then the data itself. It may also just have a single byte to indicate a simple information, like whether a channel is enabled or not. Okay, so before we can get the sensor module running, we have to write a series of config files for it. So first we're going to write to config.txt, and this is a file in the SD card on the sensor module that basically contains config information for the whole module. Right now the only keyword in there will be ID, and we'll set that to 1. Basically, the camera module has an ID of 0, and all of its children sensor modules have IDs between 1 and 9, and this is just how we identify which module we want to write to or talk to. So we'll save that. And then next we're going to write to config0.txt, which is the config file for the channel 0 sensor in the sensor module. So we'll set its type to serial. We'll set its hardware serial port to 1, which basically means over on the right here we have a pin out. It's going to be reading and writing through pins 18 and 19, TX1 and RX1. And the delimiter, which is basically the character that the sensor will send it to indicate that the reading is over. And for the specific sensor we're using, we're going to set it to 10, which is a new line character in ASCII. Okay, so that's channel 0. And then we're going to do channel 2 just to show that you don't need to do every channel in sequence. You can skip channel 1 if you want. We're going to set its type to SPI. We're going to set its chip select pin to 43, its VCC pin to 40, and its ground pin to 41. So on boot up, it'll read this information and then instantiate a SparkFun Max 31855K object that can talk to the physical ADC, and it needs these pins to instantiate that object and talk to it correctly. And as you can see on the right over here, it'll be these 3 pins. So yeah, we just save that, and then when we plug the SD card in with these files into the Arduino and boot it up, it'll read from here and gather all that information and be able to talk with those sensors. Okay, so now we're going to demo the serial interface between the Raspberry Pi camera module and the Arduino-based sensor module. So first thing we need to do is boot up the Arduino. Wait for it to load. Here we go. So booted up, read the config files. It read that the system ID was 1, And then it found config files for channels 0 and 2. It read that channel 0 is a serial sensor, and channel 2 is the SBI sensor. Okay, so we'll go over to the Raspberry Pi. I already have the test software booted up, and we'll type in our first command. So we'll say we're going to read data from device 1, channel 0, so that's the serial. And it sent the request and it got 12 bytes back and it got some dummy data. I don't have the real sensor plugged in, but it's the same code. So we read some dummy data from that. And then next we'll read from channel 2 on device 1, which is the temperature SBI sensor. And we read that it's 65 degrees in my room right now. Pretty cold. Okay, so cool, the serial interface is working. And as we can see on the Arduino side, it read those commands, one RD0 and one RD2, and then it operated on them and sent data back. So next we'll open the log files from the SD card on the Arduino and see the data that it recorded. All right, so now that we've taken those measurements, we've plugged the SD card back into my computer, and we'll open it up. And we have two new log files, one from each channel that we read from. And if we look at these, we can see data time-stamped with the time t format, and then the data that we read. So here's from the serial sensor, and then here's the temperature information we read from the SBI sensor. So yeah, essentially every time you read from a sensor, it'll just log it to these data files with a timestamp. So yeah. I measured the Arduino power consumption in 3 power modes. Power down mode yields the highest efficiency, but it disables the UART, so the idle mode must be used instead so that the Arduino can still receive serial requests from the camera module while it's asleep. However, 84 milliamps is way too high for a low power application like C-Star, so this code will probably need to be ported to another platform in the future. I have a few more tasks before my project is complete. These include implementing the rest of the serial commands on the Arduino, writing a user-friendly API for serial interfacing on the Raspberry Pi, enabling low power mode on the RPi by attaching the Sleepy Pi attachment, and characterize the Arduino's clock drift against temperature. The remainder of this demo is intended for the folks at Mbari, so classmates are not obligated to watch it. However, feel free to watch it if you'd like to hear more about how I designed some of the software on the Arduino. So I wanted to go over how I've designed a few of the components on the sensor module so that we can make changes soon if needed. Firstly, I created a sensor module struct that can conveniently keep track of the sensor module's channels. It contains an array of channel structs. Each channel struct contains an enabled parameter, and which basically means whether or not a channel is connected or not. It also indicates the type of sensor it has, and has a union called sensor that stores the parameters specific to its type of sensor. So you can either feature serial, I2C, or SBI. Since serial, I2C, and SBI interface with different APIs, I had to store different info for each. Serial sensors store a pointer to which serial object you need to use to talk to them, and a delimiter and which delimiter they use. I2C sensors just need a channel and a pointer to the ADS object, since the ADS has multiple channels. The SBI sensors, however, all require their own ADCs, so I'm just letting the user define which digital I/O pins they want to use, and then dynamically instantiate a SparkFun probe object for each SBI sensor. Config files are basically dictionaries. They just list a series of parameters or keys and values for each of them. The system and each of its channels all need to be configured with their own config files. I came up with a set of keywords to describe attributes for the system and sensors. Each sensor needs a type to determine which kind of sensor it is. It also needs type-specific parameters, like serial channels need to know which hardware serial port its sensor is connected on, and which delimiter it uses. I wrote a simple function that can search a file for a given key and return its value. For instance, If I set file to config2.txt and key to CS pin, the function would set value to 43. Soon I will implement a writing function so that changes can be made to the config files from the Raspberry Pi. The camera module requests are read into a serial buffer before being processed. The buffer has 4 slots and won't start reading until a $sign is detected. So if the Arduino receives a serial input like this, the buffer will only capture this. If the delay between characters exceeds 500 milliseconds, the command is assumed to be erroneous, and the serial buffer will be cleared, and the Arduino will go back to sleep. Finally, I want to go over how I'm reading measurements from the serial instruments. First, I start up the channel serial, and then I read bytes until I see the sensor's delimiter. So for instance, if the delimiter is new line, I'll read the bytes until I get a new line. Then I'll start actually recording the rest of the bytes. So I'll start recording from here and record until I see another delimiter, and that'll be the end of my recording. Then I'll close the channel serial and save that recording to the SD card with this timestamp. If I don't see delimiter within 1 second of recording, I'll time out and abort the measurement. So that concludes my presentation. Thank you for watching.